Hi everyone, welcome to this new lecture of hydraulic machines. In this lecture, we'll discuss the general layout of hydroelectric power plant, and we'll also discuss about that how the electricity is produced from water, or we can say how a hydroelectric power plant runs. So here I have taken a diagram from the book. You can see this is the first part of this hydroelectric power plant, a dam. This is first one, we can say this is one component, dam, and second one is here penstock is there, and third one is here we can see it is a nozzle is there, and the fourth one is here you can say this is the vane or bucket, and the fifth one is you can say the turbine, or we can say this is a runner part is there. This is actually the turbine part. In the turbine another few terminologies are there. So here I can say this is a rotor, or I can say this is a runner. So this is the fifth one, and similarly this is the shaft. This is actually the shaft is there. This is the sixth one. Anyway, this all includes about the turbine. So these are the basic parameters, or we can say basic parts or components of a hydroelectric power plant. Okay, so first we'll see the name itself, hydroelectric. This hydroelectric defines, okay, two terminologies are there, two terms are there. One is hydro, another one is electric. This hydro part came from the hydraulic, you can say. It came from the hydraulic. What is this hydro? This hydro means we can consider, we can take an example, that is water, suppose. Okay, and this electric part came from the electricity. It came from the electricity. So with the help of this water, we are going to produce the electricity. So the hydroelectric also defines, okay, it defines that the electricity produced from the energy which is in flowing or in the falling mode of water. Okay, the energy is going to, that electric energy is going to be produced from the energy of flowing or falling of water, because this hydro part is there, that is water. So this reference is given like the power will be generated. So how the power will be generated? That it need to convert the potential energy and to kinetic energy, and kinetic energy to, again we need to be converted into mechanical energy, and again it need to be converted into electrical energy. So in short form, if I can write here, so first initially it is in potential energy. So you can write this is potential energy is there. Then that is going to be converted into kinetic energy, and the kinetic energy is going to be converted into mechanical energy. So here next one is mechanical energy, and finally from the mechanical energy it is going to be converted into electrical energy. So we'll discuss all these things in this lecture. Okay, so first of all we'll see, as I told you the terminology, first we'll discuss about this, then we'll go for the energy conversions. So first, as I told you, we need to construct a dam. So this is a dam pad is there. So dam is there for water storage. So for here the first point is water storage. For storing the water, we need to produce, or we need to prepare a dam where we can store the huge amount of water. Okay, to store the water. This is for water storage. Dam is produced. So once dam is produced, completed, that development of a construction of dam is completed, then second one is we need to go for the second method or second steps, the water flow through the penstock. Okay, so penstock is nothing but actually this one, you can see, as I told you, given that this is the second one, and this cutting portion is given because this pipe is a very lengthy pipe. Okay, so the water which is stored here, you can see this one, the water which is stored here, the water is started flowing through this penstock. Okay, and penstock is nothing but this is a long pipe. Okay, this is a lengthy pipe which is constructed, or which is prepared by, you can say it can be a steel, the pipe can be a steel pipe, or it can be constructed by concrete also. So it can be anything, or you can take a long, like, a strong pipe also, like a plastic pipe also can be taken, but mostly it is to use like steel pipe or concrete pipe is to used in that. Now, this large diameter of pipes is called penstock. Large diameter of pipe is called penstock, through which the water which is stored in this tank will be flows to this one, and it will be goes and it will be comes out with the help of this nozzle. So nozzle is fitted here at this point. Okay, so the nozzle is the third one which is fitted here to increase the velocity of the fluid. Now here at this point the water is stored as I told you. So at this point the water is having potential energy. Okay, the water is having potential energy. We can write here, this is about potential energy. So we know that the potential energy equal to mgh. So that h is nothing but height. What is the height is, or what is the head is present at this point. Okay, next one, from this potential energy it is converted to kinetic energy, as I told you. First one, second one is kinetic energy. So how it is converted to kinetic energy? Initially it is in the stored condition. Now once you open this pipe, like this pipe is connected to this one, and here actually at this point we'll have a valve type will be there. Okay, some valve type will can be connected here to regulate the flow. Okay, so the water will be started flowing once this valve is open, and through this nozzle it will come out. So once it is coming out, why nozzle is kept here? Because to increase the velocity, as I told you, to increase the velocity we kept the nozzle here. And once the water is coming out from here, so the potential energy converted to here kinetic energy, because kinetic energy we know that this is half mv square. So half mv square in the sense this is also m is there, height was there, or head was there. Now the same mass already here, but here we have converted into velocity, like at what velocity the water is coming out. So that is half mv square kinetic energy. So the potential energy converted to kinetic energy. Now when it is coming out through this nozzle, it is going to strike to this turbine. So in the turbine, few terminologies are there, like as I told you, this is the shaft, and in the shaft this rotor is connected, or we can say this is a runner also. We used to call this is a runner also, runner or rotor. And these are the buckets or blades or vanes is called, this is called buckets or vanes, or we can call it as a blades also. So these are the blades or vanes are fitted on the runner, and when the water is coming out from here from this nozzle, it is going to strike to this vanes. Okay, so it will go up again, one more blade will come again, it will be struck, then it will go up. So continuously this it is struck by the water, and it continuously moving in running condition. Okay, so how many components are there? Blade, first one, it is mounted on the runner. Second one, or wheel we can say also. Now this runner is fitted with this shaft, and this shaft actually, now see this shaft as I told you. So kinetic energy struck on the jet, and this started rotating. So now here if you see, third one came turbine rotation. Due to this strike, the turbine started rotating, and this rotation actually, if you see, this rotation is converted into what we can say mechanical energy. This started rotating. So rotating in the sense that gives a you can say this is mechanical energy. This is our mechanical energy. So now this mechanical energy convert, like how it is converted from the kinetic energy to mechanical energy at the turbine position. Okay, at the turbine position, because it starts rotating, so that gives us mechanical energy. And this turbine or this shaft is connected, this shaft is actually, it is connected to a generator. Okay, this shaft is connected directly to the generator here, and this generator actually that will generate the electric energy. Now see, electricity generation in the sense what? Now this shaft, as I told you, that is connected to a generator. So this generator is going to be convert the, or is going to produce the electricity. It is going to generate electricity, and that is electric energy. So turbine is here, this turbine is like mechanical energy, turbine start rotating. So that rotation is nothing but mechanical energy. And from mechanical energy, it is going to be produced the electrical energy, or electricity is produced at the generator condition. That is the generator. So this is the process of a hydroelectric power plant. From this potential energy to this electrical energy, how it works and what are the terminology and what are the components are used here, as I told you. So this is the fourth step. The fifth step is transmission. So transmission will be done from this generator to all the places it will be started transmitting. Like it can be transmitted to all areas. Okay, all areas we can say, like if you consider, like suppose malls, residential homes, or these are the transmission process will be done with different with the help of poles. Okay. Now next one is the water discharge. Second, last one is the water discharge. Now you can see, after striking this water into this vein, the water started falling here. So this is called water discharge, and what is falling on the this container, you can say, and that is called, you can say, this line is tail race. This line is tail race, and this is the, we can say, sump level, or we can say a sump is there or a tank is there where the water is storing here after striking the blade. So this is the procedure of a hydroelectric power plant. I hope I have covered everything. Now one more few thing is there. If suddenly, now suppose if you want to suddenly close the process, if you want to suddenly close the process of this hydroelectric power plant, then again we can just put this valve here. Again we can put the valve here. Now when you when you close the valve, now suppose it is open. Now again we want to close this valve. So suddenly you close means already water started flowing and it is in the flowing condition. Correct? So if you suddenly close the valve, then what will happen? What is the pressure which is present at this water? Because see, when the water is flowing, one more thing, pressure energy is there. So pressure energy actually, this is also present in the fluid. This when the water is flowing, it is having pressure energy. It is having pressure energy as well as kinetic energy. Okay, but when it is coming out from the nozzle, this pressure energy also converted to kinetic energy because it's traveling at the atmosphere. So atmosphere pressure is here. So the pressure which is present at this, so that is also going to convert to the kinetic energy, and the water strikes with the high kinetic energy to this plate. Anyway, so the pressure which is present here, okay, suddenly if you are going to close the valve, what will happen? Again there will be a reverse force will be generated here, so that there will be a problem, or it can that kind of bursting can be happened in this pipe. So to avoid this kind of situations, here actually one more tank is fitted. One more tank is there, that is called surge tank. This is called surge tank. So this surge tank actually, when it is in the reverse condition, the water will be goes up, okay, and it will be stored here. And why this is kept? To avoid, this surge tank is kept actually to avoid the bursting in the pipes, or we can say the to avoid the water hammer. The water hammer is another terminology what we have discussed previously. So suddenly if you close anything, water hammer will be arised, and due to the water hammer, so the pipe may be blast. So to avoid that one, another tank, small tank is connected to this, that is called surge tank. So some applications of this hydroelectric power plant also there. I'll tell you some few applications are there. These are the general applications actually, and some advantages and disadvantages also there. In the application, I can say this can be applied in many places, but few are, I'll tell you. Like first here in the generation, once the electricity generated, it will be transmitted to all the places. So the electricity generation, and it is supplied to many places, as I told you, like if it is cities, then you can say cities or towns, okay, or you can say that rural areas, okay, these are the areas. And even after that also we can say like malls, okay, and industry, okay, industry will keep another one even, and this is rural area, malls, and like a restaurant, everywhere we will send the electricity. Now the second one, I can say it can be also helpful for the irrigation and water supply also. This can be also used irrigation and the water supply also. Next one, I can say one more application, industry. In the rural industry or any kind of industry, that it can be also helpful for that industry. Or also you can say the pump which is storing the storage the plants. Okay, many applications are there in this area actually, and we'll see some advantages of this, some advantages and some disadvantages also we'll discuss. Some advantages I'll write. So first one, I can say the basic, like if you see before installing a power plant, we need to obviously estimate the costing of the power plant. So here, yeah, one more disadvantage is be there. I'll write in this side, because when it is coming about the costing, we can say two things. First one is installation cost. So installation cost will be little bit more. So here we can write installation cost. Installation cost is slightly high because initially investment need to be done. And here in advantages, what I'll write? Here I can write operation cost. Here operation and maintenance cost is very, very low. Here it is high, installation cost, here it is low. Okay. Second one I can write, it is highly efficient. It is highly efficient. Highly efficient or high efficiency also we can say. Okay. And in the advantages we can write the third one. Once you have installed, it will have a long lifespan. Long lifespan is there. Long lifespan. That means it will exist of at least 100 years will be there. Okay, without any problem. And due to this, there will be no air pollutions. Okay, it won't create any kind of problem. So no, you can write air pollutions. No air pollutions, or you can say any greenhouse activity will be not there, anything. Okay, so by using these, we can reduce by the dependency on the fossil fuels. Fossil fuels. So these are some advantages are there. Even simultaneously some disadvantages are there. As I told you initially, installation cost is slightly high. And second one, we need to see some riverside areas. Area of installation only near to the, we can see like some riverside will be there. That is one more point. Third one is, okay, we can say that construction of this power plant, it will take some long time. So long time taking for construction, we can say. And next one is, I can say, while installing a power plant in that area, like riverside area, who are the populations or what are the people's living there. So to we need to displace them to a safe place, some other place. That means shifting of human beings or shifting of peoples or displacement of people also, we can say. That is one more major issue will be there. Displacement of people. So this is another one point. And yeah, so these are the some advantages and disadvantages, applications of this hydroelectric power plant. And these are the steps are there. These are the steps of working of this. And these are the names, as I told you, these are the components are there, which are used in this hydroelectric power plant. I hope you understand this theory part. Still, if you're having any doubt on this, you can give a comment on the comment box. Thank you.